Okay, now we're on page 2, and this time we're going to solve quadratics by using the quadratic formula. I'm going to write it at the top. I think we can put it up here. This is also on your formula sheet. X is equal to the opposite of b. It looks like negative b. It means the opposite of b. Plus or minus the square root. This is kind of a long one. B squared minus 4ac, and then that's all divided by 2a. I'm going to put that at the top. Now you do need to make sure you remember to put your quadratic in the standard form we talked about on page 1. So ax squared plus bx plus c equals 0. So when we get to number 4, we'll have to do that. If you look at number 3, it's already in standard form. So let's talk about this first. The a is the coefficient in front of your x squared, which is understood to be a 1. The b is the coefficient in front of the x term. In this case, it's a 2. And your c is the coefficient in front of, well, it's the constant. It's the one that doesn't have an x behind it. So those are your values for a, b, and c. Now let's put them into the quadratic equation. If you do the opposite of b on this first one, it's going to be negative 2. And then plus or minus, don't forget the square root. You're going to square your b term, minus 4, times your a term, times your c term. And then all divided by 2a. In this case, it's just 2 times 1. The part under here is the one you need to kind of look at the most. If you want, you can do it in your calculator. Let's just do that first. 2 squared minus 4 times 1 times negative 15. Since that's 64, the square root of 64, let's go ahead and write that. Your equation is going to be negative 2 plus or minus the square root of 64, this entire answer divided by 2. Now the plus and minus means there are two answers. You're going to work it out so that you have a negative 2 plus the square root of 64. You want to do it in your calculator, is 8. So the square root of 64 you're going to add with negative 2 and divide by 2. Or your second answer, you're going to do negative 2 minus 8 divided by 2. Because of the plus and minus here, you need to add and subtract your answer to the square root of 64. So on this first one, negative 2 plus 8 divided by 2, that's going to be 6 divided by 2, so that's 3. That's your first answer. And negative 2 minus 8 is a negative 10. Negative 10 divided by 2 is a negative 5. So that's your other answer. And remember, these are the x-intercepts, so if you were to graph this one, I think I'll show you that. If you push y equals on your calculator and you type in the equation, x squared plus 2x minus 15, and you push graph, what we're going to notice is they're going to hit the x-axis at these two solutions. So if you notice in the calculator, 3 is one of your x-intercepts, and negative 5 is your other x-intercept. You can't really see the entire parabola, but it is giving you the two solutions to your quadratic. Okay, number 4, this one is a little bit different because it's not solved for 0. So you have to set it equal to 0. Anytime you take something from the left side and bring it to the right, you change the sign. So instead of a positive 3x, you're going to subtract 3x on both sides. And that's going to leave you with 0. Now this is not in standard form. If you notice, the constant and the x term are flipped around. So let's rewrite it, where the minus 3x is the b term and the constant is your positive 7. On this one now, our a is 6, our b is a negative 3, and our c is a positive 7. Remember, up here we have the standard form. And all you really do with the quadratic formula is replace the variables in the formula. So let me do that right now. I'm going to kind of draw a little line here. Now remember, this negative sign means the opposite of b. So you're going to take the opposite of b, which is, since it's negative 3, you're going to make it positive 3. So positive 3 plus or minus the square root. You're going to square a negative, so I like to put it in parentheses so that you won't mess it up in the calculator. Minus 4 times your a, this time it's a 6, times your c, which is a 7. And that's all divided by 2 times the a term. This time the a term is a 6. Okay, this looks really long, but we're going to let the calculator help us out. We're going to put in the square of a negative 3. Just remember, when you square a negative number, you do have to put it in parentheses for the calculator to read it correctly. So if you type in negative 3 squared minus 4 times 6 times 7, you get a negative 159. Well, that's an interesting answer. Let me show you what happens. If you actually tried to put a negative 159 in the calculator, it would say, I'll just show it to you, the square root of a negative 159. See how it says non-real answer? Later on, if you take Algebra 2, you will learn about imaginary numbers, and you can take square roots of negative numbers, but they're called imaginary numbers. So for this course, if this ever happens and you get a negative under your radical, there is no solution. I will show you what's going to happen if we put it in our calculator. If we go back and we put in the standard form, this one right here, let's do that. 6x squared plus 7x. Oh, sorry, 6x squared. Let me start over. 6x squared minus 3x plus 7. Watch what happens when you graph it. There will not be any solutions. I don't know if you saw it, but it's way up here. There are no solutions to this equation because it does not cross the x-axis. And sometimes that does happen. So just put no solution on one like that. Okay, let's do some where we're going to solve by graphing them. And I am going to use the calculator to help you understand how to solve these. So let's turn your calculator on and go to y equals. Clear it out if there's something in your y equals. Type in 2x squared minus 3x plus 5. I'm going to go ahead and push graph. Okay, you can already tell this one is not going to have a solution. See how it's just like number 4. When we graphed it, it did not hit the x-axis. So we can sketch this one. I think I will go ahead and sketch it. Let's put on a couple of points. 0, 5 is a point. 1, 4 is a point. 2, 7. 3, 14, that won't fit. Negative 1, 10. Okay. Let's not worry about where the vertex is on this one. This one, if you push graph again, it does kind of go down. Probably goes down, dips a little bit more, and goes back up. So there's a sketch of that graph. But remember, since it doesn't hit the x-axis, there is no solution. Go ahead and write no solution on that one. Alright, let's try the next one. Go into y equals, and let's type this one in, negative 3x squared minus x plus 7. Push graph. Okay, this is the first one we've had where the parabola is actually now the vertex is a maximum because it does go up and around. So on this one, because it's a negative 3x squared, it looks like it doesn't hit the x-axis at exact points, and I'm going to show you how to get that one in just a second. But let's go ahead and see if we can figure out where some of these points are. Okay, -1 goes to the +5. 0 is at 7. 1 is at 3. 2 is at -7. Alright, I think I'm going to show you how to figure out where the vertex point is on a graph like this. I'm going to use the calculator for a second before I finish graphing it. When you do this, you go to your graph and look at your graph, and if you want to see the word, the button at the top that says trace, if you go to second trace, the calculate button, you can go to what's called the maximum. So go to number 4, it says maximum, and push enter. Now you're going to see something on your calculator. Let me see if I can zoom this in. That might help you see it a little bit better. If you, let's see if that helps. Alright, see how it says left bound and then the cursor's kind of blinking at the top? What that means is somewhere up here is the vertex. It's kind of hard to tell on the screen. So left bound just means get your cursor to the left side of where you want your maximum point, where you want it to finish up. So I'm going to move the right arrow key. I think you can see the cursor moving, but I am on the left side of that maximum point. So go ahead and push enter, and you'll see a little arrow come up at the top, and then it'll say right bound. So this time I'm going to push the right arrow key, and if you'll notice, as you click it, the little cursor moves, and now I'm on, I don't know if you can tell, but it's now over on the right side of that vertex point. So once you get it to the right side, go ahead and push enter. Now it does ask you to guess. After it puts the little 2 arrows up here, it'll say guess, but I'm going to skip that, so just push enter. It'll take a few seconds, but it will tell you where your maximum point is. So let's write that on here. Our maximum point is at -0.16 repeating as your x coordinate, and 7.08 approximately for your y coordinate. So that's a pretty tiny little number to work on, but let's see if we can kind of graph that. -0.1 is really close to the y-axis, so I'm just going to stay kind of close to the y-axis and go up a little bit past the 7. If you notice, 0 is right at the 7, so it is, we were pretty close in our parabola. Okay, I'm pretty accurate on this side. I'm kind of missing some points over here, so I'm going to go back to my table. Let me zoom back out for a minute. See if it focuses for you. And I'm going to look at some points on the negative side. -1 is at +5. I did that one. -2 is at -3. And if I want to put another one on, it won't fit because it's -3, -17. So those are some exact points I can put on my parabola. It's kind of a little lopsided, but anyway, it's not perfect. If you want a perfect one, push the calculator and it'll give you one that's perfect. Alright, we still haven't actually found the solutions. Solving this quadratic by graphing, I'm going to show you the way that we found this maximum point is also how you find these points of intersection. I don't know how well I've graphed this, but can you tell they don't go through exact points? When that happens, you will need to use the trace button again. Second trace. If you go to, see the word 0, number 2, if you go to that one and push enter, you're gonna have to do the same thing with the left bound, right bound. So we're gonna have to move our cursor. I'll do the one over on this side first. We're gonna get to the left side and push enter. That means you're gonna be below this point right here. To get to the right side, you're gonna need to move the cursor up a little bit. Go above the x-axis so you've moved it up. And if you push enter, you'll see the arrows are kind of close together, but they are on the left side. Now I'm not going to guess, I'm just going to push enter, and it's going to tell me, I think you can see it on the calculator, it's blinking and it tells me what the intersection is. So this point right here is a little past the -1, almost to the -2. My graph is actually pretty good. It's at a -1.7. It's a little more than that, but we'll just round off. So this is one of your solutions. Actually, x equals -1.7 is pretty close. Now let's try the other side. You still go back to second trace, number 2. This time the left side I'm going to move and be a little bit above, well, let me go a little bit more. If you're above the x-axis but you're blinking on this side, you're on the left side. The right side, I'm going to need to move my little cursor down below the x-axis. And see the two arrows at the top? Now they're on left and right side of that intercept right there. Push enter to skip through the guess, and then see how it tells you the point. Right here, this intersection point, let me just point to this one over here. This solution is my second solution, and it's at 1 point. We'll just round that to 370. These are kind of crazy answers, but this is one of your answers. X is equal to 1.37 is a solution, and x is equal to -1.7. These are rounded answers. These are not exact answers, but we use the calculator to help us. Come see me if you're still not understanding that, and I'll give you better hands-on instruction. Just bring the packet up to me and I'll show you how to do it. Okay, this next one says solve the following quadratic equation by your method of your choice. When I look at this one, before I even start, the numbers are kind of big, so I probably wouldn't choose factoring. I might try graphing it. Let's try that first, and if it doesn't look like it's going through an exact point, kind of like number 6, I would probably use quadratic formula, but I think I'll see what the calculator tells me. So 9x squared plus 12x. Again, this is not in standard form. This 1 is on the right side of the equal sign, and it's positive, so to bring it over, it would become a negative. So it's 9x squared plus 12x minus 1 equals 0. Let's put that in the calculator and see what happens. 9x squared plus 12x minus 1. Now remember, the equals 0 part, you don't put that in, you just put in the standard form. And let's push graph. Okay, you can kind of see it might hit at the origin here. Let's go to the table and see. Nope, not quite. See how it's not hitting exactly at it? So what that tells me when I put it in the calculator like this is that it's going to be more like the one we just did with number 6, where it does not hit at an exact point. So if you're having trouble understanding the second calculating part of doing it, I think I am going to show you how to do this one with quadratic formula. I don't think I would choose graphing on this one. On this one, it's probably easier to use the quadratic formula, even though the numbers might be a little bit bigger. Okay. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times your a times your c. And all of that, remember, is divided by 2 times your a. So let's try that. Negative 12 plus or minus. Let's get this. This is actually called the discriminant. Let's get the discriminant and use the calculator. 12 squared minus 4 times 9 times negative 1 is 180. And then 2 times 9 is 18. So you're going to have, when you work these out, make sure when you type it in, you're going to do negative 12 plus the square root of 180. And then you're going to divide that by 18. That'll be one of your answers. And then you're going to do x is equal to negative 12 minus the square root of 180 and divide that by 18. Okay, I'm kind of running out of paper here, but let me move this over. This is very important. I want you to listen closely. When you type in negative 12 plus the square root of 180, you can close the Radican, but if you were to put divide by 18, you would get the wrong answer because it would divide the square root of 180 by 18 and not the sum. So you do need to push enter and then divide by 18. And that would leave you with this first answer, 0.07. We'll check that in the calculator on the graph in just a second. Let's try the next one. Negative 12 minus the square root of 180. And go ahead and push enter, remember, before you divide by 18. Your other answer here is a negative 1.4. Okay, let's check those. Let's go back to our graph and let's review using the second trace button. If you push second trace and you go to one of your zeros, see the second one says 0, you push enter. Now this is going to be a little harder to do because it's so tiny, but to get to the left side, we'll just do the left side of that parabola first. I need to be above the x-axis before I push enter. Now to get to the right side, we just need to be below the x-axis. Now the arrows are kind of close together on this, but I think it'll work. See how negative 1.4 is one of your answers? Remember how we got that when we used the quadratic formula? So it worked. We got the negative 1.4. Now let's use our second trace, number 2, one more time. This time we're going to do the right side of the parabola, but when it says left bound, you need to be below the x-axis because we're doing the right side. So push enter. Move the cursor above the x-axis to be on the right side. Push enter. These arrows are kind of tiny, but go ahead and push enter. Just skip guess by pushing enter. And if you notice, it does say, I don't know if you can see it, but it says 0.078. That was exactly the answer we got a minute ago, if you remember, when we divided by 18 after we worked it out with the quadratic formula. So that is the correct answer. If you did want to sketch a graph of this, you might want to 0.07 is really close to the 0, and it's the positive side, but it's tiny bit past, so I'll just put a little dot right there. And then negative 1.4 is not quite halfway. Now if you wanted to sketch this one, let's kind of use the calculator, maybe we can get a couple of other points. 0, negative 1 is a point. Negative 1, negative 4 is a point. The vertex point, you know what, let's use the calculator. Let's go find now this one's a minimum, not a maximum, because it's a parabola that's facing downward. Okay, the cursor's not on the left side, so let's move it. Now it's on the left side. Now it's on the right side of my lowest point. I'm not going to guess. So the actual vertex point, or the minimum point on this one, let me move this up, is at negative 0.6, which is a little bit past a half, and then negative 5. So a little bit past a half on the negative side, and 1, 2, 3, 4, 5. So about right there. I'll move this out of the way. So if you were sketching your skinny little parabola here, oops, oh well, not great, but it's okay. That would be the graph of that quadratic. Okay, try these on your own.